Perch in a lake have a mean length of 20 centimeters and a standard deviation of 5 centimeters. We're asked to find the percent of the population that is less than or equal to the following lengths. In other words, we want to know what the percentile is for that particular data value. So the first one is 22 centimeters, and I've gone ahead and subbed into our equation for z-scores, so you can just check your work. So the z-score is equal to, and the data value is 22, subtract the mean, which is 20, divided by the standard deviation, which is 5. And so this simplifies to be 0.04. So now if we go to our z-score table, and what I need to do is find 0.4. And since it's 0.40, we go to 0. And so it'll be this value here, which means that that particular data value is equal to the 65th 0.5 percentile. And I won't put the equals in there because I don't want to confuse that with what the z-score is, but it corresponds. A z-score of 0.4 represents a data value that is in the 65th percentile, 65th 0.5 percentile. So next one, I've gone through and subbed in, and I got a z-score of negative 0.8. And again, I have to scroll down, find 0.08, and there is no remainder here. So here is 0.08, so that's approximately in the 21st percentile. In other words, that particular data value will be greater than 21% of the fish in the lake. The next one, the z-score for a value of 28 would be equal to 1.6. And when I go to 1.6, then you can see that this is in approximately the 94.5 percentile, 95th percentile. I'm just going to say 95th percentile. Because this will be an estimate. Now, if you notice, the next one is negative 3.2 as your z-score. And so when you go to your z-score table, you'll notice that there is no value for negative 3.2. The greatest we can go up to is negative 2.99. And so what we can do then is go back to Excel. Right, so when I launch Excel, I'm going to use the z-scores, calculate the percentile. So this is going to be norm dist. And so in a case where I don't even need to calculate the z-score here, my data value for the first one was 22. The mean was 20. The standard deviation was 5. And for cumulative, I'm going to say true. And so you'll notice that it returns a value of 65.5%. And I can actually change that to a percent so that it matches what we saw before. And so if I change this value now to 16, which was the next one, I get 21.2%. The next one was 28. You'll notice that this is doing all the same calculations as we just did. So there's 94.5%. And so now I've got something off the table, the Z-score table. And so I'm going to put in 4, and it says 0.1%, but if I add some more decimals, it's 0.007%. So this is very unlikely that there's any fish smaller than this one in the lake. This would be one of the smallest fish in the lake, if not the smallest.